So in this video, we're going to review factoring when there is a 1 in front of x squared. So our coefficient is not really worrisome when we just have a 1 in front of x squared. And we'll see an example later of when we have something other than 1 in front of x squared. But let's recall when factoring a quadratic expression like these, where we have x to the second power, something times x, and then something else out to the side, we want to put two parentheses. All right, now, x squared is easy. We need x times x to give us x squared. So the first part of the parentheses is going to be x and x when we just have x squared as our first term. Now, we're going to look at the last term. It's a positive 20, and we need to think of things that multiply to give us 20. But we want those to add up to 12. All right, so if we think of positive 20, we could have 4 and 5. That adds to 9. We could have 1 and 20, but that adds to 21. So 2 and 10 are the two things that when multiplied gives us 20, but add to 12. So we're going to have plus 2, oops, except I can't type, and plus 10. Now note, we can always check our factoring. It's not necessary to check your factoring once you get this process to where you really understand it. However, we can check it. So we can go x times x is x squared. We can do x times 10 is 10x. And then we can do 2 times x is 2x. And then we can do 2 times 10, which is 20. And notice if we add our middle terms, they are like terms. 10x plus 2x is 12x. And of course, we get the expression that we started with back again. It's not necessary to do this every time, so we won't do it, but that does tell you how you can check those. All right, so let's look at the next one, and let's make our parentheses. And we need x and x to get our x squared just as before. And now we need to think of two things that multiply to give us a positive 42, but add to negative 13. Now the only way we're going to get negatives is to multiply two negatives to get our positive 42, because two negatives multiplied give us a positive. So we need to think of factors of 42. Well, the one that comes first to mind is 6 times 7, but we said we need them to be negative. So negative 6 and negative 7 will multiply to give us 42. And let's notice negative 6 and negative 7 add to negative 13. So that is our two possibilities. Now, it doesn't matter which one I put first. So if I put the x minus 7 and then the x minus 6, that's the same thing. We can multiply the two out of order. And that doesn't look too good, but... All right, so let's go to the next one. Same thing. Let's make our parentheses. I don't know why it skipped ahead like that, but... And we know we need x and x. All right, so we need factors of negative 18 that add to negative 3. Now, immediately the first thing that comes to mind when we think of 18 is 9 and 2. And we would need one negative and one positive to get a negative 18. But 9, even if we have negative 9 and positive 2, that's going to add to negative 7. Or if we have 9 and negative 2, that will add to positive 7. It doesn't give us our minus 3. So other possibilities for 18. Well, let's think 6 times 3 gives us 18. So if you have a negative 6 and a positive 3, that will add to minus 3. So negative 6 and positive 3. And there's our two factors. All right, so let's do this next one. Same thing, make our parentheses. And let's put x and x. And then now we need factors of negative 16. Again, one's got to be negative and one's got to be positive to get a negative 16. We can think 4 and 4, but a negative 4 and a positive 4 are going to add to 0, and that's not going to give us this 4 here. So we have to think of other factors. And oops, I think I made a mistake in making... No, I didn't. Yeah, I did. Let's change this one up. I made a mistake in making the problem up because it's not going to work. Let's change that to, oops, to 6x, and it'll work. 6x. Now, had it not worked, as I had previously, we would call it prime. We can't factor something that's prime, but I meant for it to work. All right, so 4 and negative 4 still does not work here. Let's think of 8 and 2 are factors of 16. A negative 8 and a positive 2 would add to a negative 6, but a positive 8 and a negative 2 would add to 6. So we need a positive 8 and a negative 2. And there's our two factors. All right, and let's do our last one here. Make our two parentheses. Let's put our x's in the front. And then we need factors of negative 14 that add to negative 5. Now, since it's a negative 14, we're going to need one negative and one positive to multiply to minus 14. And of course, 14, immediately we think of 7 and 2. And if it's a negative 7 and a positive 2, that would add up to negative 5. So negative 7 and positive 2. And there's our two factors. All right, now let's practice a little bit taking out a greatest common factor or a GCF. We're going to see some problems where we have bigger exponents and we want to take out a greatest common factor first. When we see these problems, we want to look at all of the numbers in our terms and take out the biggest number that will divide evenly into all of the terms we have. In this case, a 3 will go into 3, 12, and 15. So I'm certainly going to take out a 3. As far as my variables go, I want to take out the variable to the smallest power. So I have x cubed, I have x squared, and I have an x to the first right here. X to the first is the smallest power, so we can take out an x to the first. Now, when we decide what's left, we'll say 3 into 3 goes 1 time. Now, I don't need a 1 in front of what's left. I can always write it without the 1, but we can put the 1 there if we want to. And then I'll say 3 minus the exponent of 1 that I took out leaves me an x squared right here. Or we could have just written x squared and not put the 1 in front there. All right, now 3 into 12 will go 4 times, and then 2 minus the 1 exponent that I took out gives me an x. And then 3 into 15 goes 5 times. And then if I think of this x to the first and this x to the first and subtract them, that's x to the 0, which really just gives us the constant 5. Anything to the 0 power is 1, so you can think, okay, that's really just stays with the 5 times 1, and it's just 5. All right, so in our next one, 4, 12, and 24, we can divide each one of those by 4. And then our smallest exponent is x to the third power. So we're going to take out x to the third. All right, so we are left with 4 goes into 4 1 time, and then the 5 minus the 3 gives us an x squared. And then 4 into 12 goes 3 times, and the 4 minus the 3 gives us x. And then 4 goes into the 24 6 times, and the x cubed cancels out. So it's just 6. Now, it could be that these right here factor further, but notice I'm really just saying taking out a greatest common factor here, so we're not going to worry about them factoring further. If they did factor further, we would be back to these steps up here to factor this stuff in the parentheses. And it doesn't look like that factors. If that was a minus 5, it would probably factor. Same thing here. Doesn't look like it's going to factor. All right, so let's go to this last one. I'm going to take out of 10, 15, and 20. Well, a 5 goes into all of them. And it looks like it's just x to the first is the smallest exponent. So 5 into 10 goes twice. 4 minus the unwritten 1 on the x gives me x to the third power left over. And then 5 into 15 will go 3 times. And the 3 minus the unwritten 1 gives me x squared left over. And then finally 5 goes into 20 4 times. And then the x's cancel out, so we just have 4. Now, be careful in your instructions as you're doing the homework. If it just says to factor out a greatest common factor, don't feel like you have to try to factor the stuff that you've left in the parentheses. You'll just be doing this portion and stopping.